Hello, welcome to Projects, Topics, and Electronics. Today's video I'm going to go through a quick summary of my DIY RC plane build. So this is the final product of my DIY RC plane build. Overall, the project took a little over a month to complete and contains a plane. This frame is the FT Spear by Flite test, the free plans of which are available on their website, a custom 3D printed transmitter box, custom TX and RX PCB boards, 2 Arduinos, a battery, and an 1100 kV motor with 30 amp ESC. So, just to give a quick demo here. So, up, down, left, right, and throttle. So the code to implement all the functions was one of the larger pieces of software I've ever written. So yeah, one of the programs I wrote was a program to set the throws on the servos. I just made it so all I have to do is move the elevons to the desired position and then press a command through the serial monitor on the Arduino, and then it stores that value automatically and maps it accordingly. In addition, I also wrote some simple trim functions just so I can throw them in the code and trim it up and down if I want. Now, since my transmitter box is indeed just a very simple transmitter box, I can't do any on-the-fly trimming because I didn't put any potentiometers for that on the box. So if the wings are not totally balanced when I'm flying them, then I'm just going to have to compensate for that. For actually sending the commands to the plane from the transmitter, I leaned heavily on the NRF24 library, which is available on GitHub, and I'll post a link in the description below for that. And if you watch the in-build videos, you'll know that I had to tie the PWM pins of the Arduino to the AT Megachip 16-bit timers rather than the 8-bit timers to gain additional resolution. Now just to give a quick tour here, on the left-hand side of the plane is the NRF24L01 Plus dev board. Now this is not the same version as I cover in the DIY NRF dev board series. This version is actually the first version I ever made and has just the NRF chip on it and is bidirectional. The version that I covered in the video series is in the transmitter. Now I thought a lot about where to place the antenna and ended up sticking it out the side here. At this location I figure if the plane does some wing over wing rolls or flips over, it should hopefully rotate this antenna so that it doesn't get damaged or break off the board or something like that. Also, the board is just velcroed in the frame here, so if it gets jarred from this direction, hopefully it just pops the board loose and doesn't break anything. Also, in the previous series I did a simple range test and determined that it would probably be sufficient enough to fly a plane. However, I am definitely testing this in the middle of nowhere, because there is really no scenario here where the plane does not crash. So I am practicing safety just as you should as well. Also, be sure to abide by all FCC guidelines if you are doing projects like this or even just flying, a plane with factory equipment. The FCC guidelines are there for a reason, and the less incidents that happen in the hobby now, the safer and less regulated it'll be for the future to come. Now, if I can't obtain solid communications with the board setups that I have, I did actually purchase a pre-made NRF24L01 Plus board, and that one actually also includes a low noise amplifier, which mine does not have. So the low noise amplifier alone should greatly increase the effective range of my communication system if the custom boards are not up to the task, and it should add a lot to my communications integrity. Anyways, on the right side of the craft is the cavity that houses the onboard Arduino, which actually you can't see at all because it's all covered in wiring. So I did a pretty decent job keeping the wiring all clean up in here until I get to this area. So I don't actually have a crimper to be able to make my own custom length leads, but I did have some pre-crimped parts, or some pre-crimped wires. So rather than trying to cut them apart and solder them shorter, I just stuffed them all in this cavity. And I was going to mount the Arduino more securely. It's actually just freely sitting in here right now. But honestly, there's so many wires packed in here, I don't think the Arduino is going anywhere. In the front of the craft, is where I'll mount the battery, and actually that'll be all that goes in the front. Now this little battery here I'm just using for testing purposes. I have a much larger battery on order to when I actually fly this plane. And then just in the back here I have actually a factory purchased ESC that provides, which if you also watch the video series, this ESC has a battery eliminator circuit on it that is providing 5 volts to the entire control system. And then finally right here, the 1100 kV motor. That's really about it. Overall, for the first attempt, I'm not really too dissatisfied with the results. However, there are definitely a few things that have room for improvement. And I'm actually going to be setting the bar for success in this project quite low, because at this point I'm a little bit skeptical as to how well it's actually going to fly. The biggest issue, which I touched on in the build series, is the joystick on this transmitter. So if you've thought about doing a project like this, or you're in the middle of it, you may have thought, oh wow, it'd be really cool to control my plane with like an Xbox controller or a PS2 joystick. However, there's a reason why factory transmitters have very tall joysticks with a lot of throw on them. And that is, you can get a lot more resolution and precision in your control with a taller joystick that has a lot more throw. Moving the joystick on this actually, it's so sensitive, it takes such little movement to be able to get the full travel of the servos. And I put some expo functions in my code as well, but like I said, this travel is so little, I don't think expo is really going to help me at all. Now I could put extenders on this joystick. However, I already made the box quite thick, and by the time I get an extender on there, my thumb will be how high off the joist, or how high off the bottom of the box, and I just don't think it'll be very comfortable to fly if I put an extender on the joystick. So yeah, the joystick is definitely the biggest issue I think I'm going to run into with this design. And aside from that, really just everything else is just kind of some small stuff, mostly with the transmitter box. I am by no means a CAD designer. I am definitely not a pro at using SolidWorks, and I made a few small mistakes in there that just kind of irritate me, but at this point I've decided that this will be revision 1. I think I'm definitely going to come back to this project with a revision 2 in the future. I think I got some kind of cool ideas for that, so yep, I will be returning to this concept in the future. So that pretty well wraps up this overview video on the DIY RC transmitter. All that's left to do now is to go out and give it a test fly, and probably a few crashes. I want to thank you guys for watching Projects, Topics, and Electronics, and I'll see you in the next video.